Hello, everyone. Good morning. Yes, still morning. I want to tell you a little about what we've been doing in the physics department with online education and our teaching of quantum mechanics. I've been helped in this by Saif Ryan and Jolyon Bloomfield that have been working with me on this matter for a few years already. So here is the quantum mechanics sequence at MIT. That's how we teach the subject. We're one of the few schools that has 3 courses at the undergraduate level. This is 804, the first course in quantum mechanics, where you learn some of the basics of the subject. 805, you get into spin 1/2, bracket notation, dynamics, entanglement, and angular momentum. And 806 is slightly more advanced, in which you have approximation methods and subjects that in some schools would be done at the graduate level. So here is how we organize the teaching of quantum mechanics using the fall semester and the spring semester. 804, the course that is taken by most of the students, is taught 2 times a year. And before 2015, it was taught exactly in the same way. 805 is only taught once a year. It's a slightly more advanced course, and the fact that it's only taught once a year causes some scheduling problems for a number of students. 806, the last course of the sequence, is taught also once a year, and a student can go from 804 to 805 and 806 one semester after the other. Well, that's going to change. The way it's going to be now and probably for a while in the future is the following. 804, that was taught twice a year, is going to be taught in online blended form one semester, and in the same way as before, but enhanced by tools from MITx and online tools to help the course run a little more efficiently. 805 is going to be taught now twice a year, so these are the novelties. And this semester is just again going to borrow some tools that we are developing online. And here is basically a fully online course with blended learning, and that actually, after experimenting with it for already 2 years, it has become a permanent course in the MIT curriculum. The Committee on Curriculum approved this course. It's totally different from the conventional course. 806 will be enhanced in the future. We're working on this course at this moment. So here is how a traditional course compares to an online course. Here is a traditional 805, say the second course, and here is the online course that is offered to the whole world, 805X. We've made a point in every time we're teaching these courses is that we run the online course at MIT simultaneously with the MIT X course for the whole world, so we get a lot of insight about the different populations. Now, when we go into a blended format, we take things from each of the elements. So from the traditional course, we keep recitations for 2 hours a week, we keep paper exams, and we adopt from the online tools lecture videos that are cut with checkpoint exercises, tutorial videos where we discuss extra problems or some ideas, and computer-graded homework. So this was the class of 2015, the first experimental class. These are the students. Saif Ryan is in here. I'm somewhere there, a little bit here. And it's a very enthusiastic class of students. Students were very proud to be part of this experiment, and the course was very successful by their comments. We also enjoy, and Professor Ike Chuan has supported some investigation with enormous data, thousands of students taking these things online, and students at MIT. For each problem, we can get a curve with some parameters that tells us how difficult is the problem and how discriminating it is. I will not go into the details, but basically you have 3 parameters to fit. A discrimination of slope. Here, this function is the probability that the student will get the answer right. So as the ability of the student, plotted here with theta, increases, the probability to get it right increases. Then, for each problem, you get the parameter B that characterizes the difficulty, and A with the slope, the discrimination. So it's very interesting to actually do this thing with an enormous database, and each problem we have an idea how difficult it is and how students react to it. So let me tell you about some features that we've learned, how the students take this thing. What they like, what they disliked. There's flexibility on their schedules. You see, the lecture videos, they can see it at any time, and they like it. They like to watch them at night. They like to watch them in their bedrooms. They like to watch one video, go run around the track, return for the second video. It's very nice. These lecture segments can also be paused, heard again, and understood. Indeed, that solves a little bit the problem that if an instructor is talking to a student for an hour and 20 minutes, and they suddenly get lost and decouple or have to take notes, the students like to watch the videos at their pace, pause them, hear them again, understood. They tell me that when they don't understand something and they hear it again, they usually understand it the second time. So in between the little videos of segments that comprise a lecture, there are lecture exercises that are very important and very useful. They also prepare the students for recitations, because when they come, they've done all that. And as Carl was telling us in his talk, we need to be able to teach the students after they've put some expertise into their brains. So another thing that is useful is that the problem sets get feedback at the right time. Being online, the homework, they get the feedback after they solve the problem immediately, and at that time they have all those questions, what did I do wrong, what did I do right, as opposed to getting the homework 2 weeks after and being able to look at it. They say the online grader doesn't give them much feedback, no good partial credit, and they would like to be able to print the material a little bit better, and that's some of the things they complain. But let me just conclude by saying a few things. The quantum sequence is very important for the MIT undergraduate education, and we would like to get it right. I think we've been developing it, and hearing Carl's talk, I feel a little bit that we should do some thinking as this evolves and optimize it in several ways. This has all been possible because the technology is just amazing. Online homework is unbelievable. You can put in a formula, write it in 100 different ways. The grader will be able to tell whether it's right or wrong. There's tools developed by the mathematics department for sketching functions. There are all kinds of amazing things that can be done. As I told you, one of these courses already became a permanent. The second course may become permanent as well. And we think that the online tools will help the conventional courses. We will finish this sequence in 2019, and MIT will have full resources for undergraduate quantum mechanics. Let's hope we can rethink it and make it the most efficient as possible. Thank you very much.